Hi everyone! Welcome to another episode here on ICCT Online Learning, your go-to channel for insightful tutorials and discussions. Today, we're diving into a fascinating topic that's at the core of every computer or device you use: operating system as platforms. Have you ever wondered how your computer knows what to do when you open an app or save a file? That's where operating systems comes in. They're like the brain behind the machine, making everything run smoothly. By the end of this video, you'll have a deeper understanding of what operating systems do, why they're important, and how they make our devices functional. Let's stick around as we unravel the essential topic. Let's get started. Before we dive in, let's quickly outline what we're going to learn today. These are the key takeaways you'll get from this tutorial. First, we'll define the role of an operating system or OS and why it's such a critical platform in computing. Next, we'll explore the core function of operating systems, including how they manage hardware and software interaction. We'll also learn about the different types of operating systems and how they are used in various scenarios. And finally, we'll talk about the OS role in managing resources, ensuring security, and providing a user-friendly interface. So whether you're a tech enthusiast or a student learning the basics, this video has something valuable for you. Alright, let's kick things off by answering a simple question. What is an operating system? Imagine trying to use your computer without an operating system. It would be like speaking to someone who doesn't understand your language. The OS acts as a translator, a middleman between the hardware of your device, like the CPU and memory, and the software application you want to use, like your browser or word processor. Without an operating system, your computer would just be a collection of parts completely unusable. It's the OS that brings it all together, enabling you to interact with your device seamlessly. And it's not just limited computers. It's not just limited to computers. Operating systems are everywhere. In your smartphone, smart home devices, cars, or even supercomputers. They provide the foundation that makes all of these devices work. Cool, right? Now that we know what an operating system is, let's talk about what it actually does. An OS is like the multitasking genius of your device. It performs several critical functions to keep everything running smoothly. First up, we have resource management. The OS manages all the physical resources of your device, like the CPU, memory, and storage. It decides how much of these resources each application gets, ensuring everything runs efficiently. For example, when you're working on a project and have multiple apps open, the OS makes sure the processor isn't overwhelmed. Next is process management. Think of this as the OS juggling multiple tasks at once. For instance, if you're streaming music while typing a document, the OS switches between these processes so both can run seamlessly without interrupting each other. Another big job is memory management. The OS handles your device memory like RAM is allocated to different applications. If you've ever opened multiple browser tabs at once, you've experienced memory management in action. Each tab gets its own portion of memory to operate without interfering with the others. And that's just the beginning. we'll dig deeper into other functions like file system management, security, and user interfaces in the next part of the video, so stay tuned. Alright, let's continue exploring the core function of an operating system. We already talked about resource, process, and memory management, but the OS doesn't stop there. Next, we have file system management. The OS is responsible for organizing and storing all your data on devices like hard drive or SSDs. Think about how your files are neatly categorized into folders and subfolders. That's the OS working behind the scenes. It uses specific file system like NTFS for Windows, APFS for Mac OS, or ext4 for Linux to make sure your data is stored securely and can be retrieved quickly when needed. Now let's talk about security and access control. A good operating system protects your device from unauthorized access and potential threats. Features like password, biometric authentication, or even permissions for accessing files are all part of the OS security toolbox. For example, when you unlock your phone with a fingerprint or Face ID, you're using an OS security feature. And finally, there's the user interface or UI. This is how you interact with your device. It could be a graphical interface like the one you see on Windows or Mac OS, or a command line interface like those used by Linux power users. The OS makes sure you can give commands and access features in a way that's intuitive and user-friendly. Now that we know what operating systems do, let's take a look at the different types of OS and their unique roles. First, we have desktop operating system. These are what most of us are familiar with. They're designed for personal computers and laptops, including examples include Windows, which is known for its user-friendly interface, Mac OS, which is loved for its sleek design and tight integration with Apple hardware, and Linux, an open-source OS popular among developers. Then there are mobile operating systems like Android and iOS. These are optimized for smartphones and tablets, focusing on touch-based navigation and energy efficiency. Android, with its open-source flexibility, powers most smartphones worldwide, while iOS is famous for its smooth ecosystem and robust security. Next up is server operating systems. These are designed to manage servers and prioritize stability, performance, and scalability. Examples include Windows servers and Linux distribution like Ubuntu Server, which are widely used for web hosting and cloud services. We also have embedded operating system, which run on devices where computing isn't the primary function. Like smart appliances or automotive systems, examples include RTOS used in critical systems like medical devices and FreeRTOS for IoT devices. Lastly, we have cloud-based operating systems designed for managing virtual resources in cloud environments. VMware vSphere and Google Chrome OS are great examples, enabling efficient use of cloud platforms. Let's switch gears and talk about one of the most critical roles of an operating system: security. An OS serves as the first line of defense for your device, protecting it from unauthorized access and malicious attacks. How does it do this? Through key features like user authentication, which verifies your identity using password, biometric, or even tokens. It also enforces access control, which defines what each user or application is allowed to do. For example, You might not have the same permission as an administrator, and that's intentional. It's a security feature. Another important aspect is encryption, which converts sensitive data into unreadable formats that can only be accessed with the right decryption key. Finally, the OS integrates firewall and antivirus support to block harmful software and manage network traffic. Operating systems like Linux are particularly known for their security because of their open source nature, allowing for quick vulnerability detection and patching. On the other hand, commercial systems like Windows focus on user-friendly security features to cater to a broad audience. Modern computing has evolved to a point where different operating systems often need to coexist and work together. This is what we call the OS ecosystem, and it's made possible through technologies like virtualization and interoperability. For example, a dual boot systems allows you to run multiple operating systems on the same machine. You could have Windows for gaming and Linux for development, switching between them as needed. Then there's virtualization, which lets you create virtual machines that run on different operating systems on a single hardware platform. Tools like VMware or VirtualBox makes this possible, and they are widely used in enterprise environment. Finally, we have containers, like those managed by Docker. Containers allow application to run consistently across different operating systems, making them ideal for developers who need to test and deploy software in multiple environments. These technologies highlight how adaptable and versatile operating systems have become in today's interconnected world. Let's wrap things up with some key takeaways from today's discussion. 1. Operating systems are the essential platforms that enable hardware and software to interact seamlessly. 2. They perform critical functions like resource management, process handling, memory allocation, and user interface provision. 3. Different types of operating systems cater to unique use cases, from personal computing to cloud-based services. 4. Security is a cornerstone of any OS, providing features like authentication, encryption, and access control. Finally, technologies like virtualization and containerization demonstrate the adaptability of operating system in today's IT environments. With this knowledge, I hope you have a better appreciation of the role operating systems play in making our digital lives possible. And that wraps up our tutorial on operating systems as platforms. I hope you find this session both informative and engaging. Operating systems are truly the unsung heroes of our digital world, quietly ensuring that everything works seamlessly behind the scenes. If you enjoyed this video and learned something new, don't forget to like, share, and subscribe to ICCT Online Learning for more insightful tutorial and discussion. Also, feel free to leave your question or thoughts in the comments below. I'd love to hear from you. Thank you.
For more ICCT College's video updates, please subscribe and click the notification button.